have a few important review questions to make sure you're thinking clearly about kinematics and motion with a constant acceleration. So these are all for one-dimensional kinematics. First question, you throw a ball straight up into the air at the highest point. The balls, is it velocity and acceleration are both zero? Velocity is non-zero, but the acceleration is zero. Acceleration is non-zero, but the velocity is zero. Velocity and acceleration are both non-zero. So think it through, talk it over with your neighbors if you can, and then when you have an answer, go ahead in the slideshow here. The first thing that I want to do is eliminate choices 2 and 4. This is based on the idea that if I'm throwing the ball straight up in the air at the highest point, the ball is neither going up nor down, so the velocity of the ball has to go through 0. So just saying you're at the highest point means the velocity is 0, because it's neither going up at that instant any further, so it is the highest point, but it's not yet started to go down. So the velocity does have to go through 0. So now we're down to choices 1 and 3, which comes down to, is the acceleration 0 or is the acceleration non-zero? So when you're done talking through that, come to a conclusion for yourself. Let's go ahead in the video. All right, so the ball thrown straight up in the air at the highest point, velocity is 0, the acceleration is non-zero. That is saying that the velocity continues to change all throughout the motion of the ball going up and then coming back down. Right. What I want you to come away from this question with is an understanding that if you believe that the velocity and acceleration are both 0 at the highest point, then what you're saying is sort of magical thinking. My pencil gets to the highest point and it will just stay there. The velocity is 0 at the highest point. If the acceleration is also 0 at the highest point, then the pencil would never move again. Okay? So obviously that's not what happens. It falls back down because the acceleration is not 0. That is making the velocity continue to change at a constant rate. So it falls back down. All right, let's try a couple more. If I drop an object in the absence of air resistance, it's going to accelerate downward at 9.8 meters per second squared, roughly 10 meters per second squared. But instead I throw it down. This downward acceleration after release is it less than 9.8 meters per second squared? It's exactly 9.8 meters per second squared, or more than 9.8 meters per second squared. So read through the question, think it through, talk it over with your neighbors if you can, and pause the video until you have an answer, and then let's go over it. All right, so this is actually my test for Jedi. I have asked this question many, many times over many, many semesters, and I have never found a Jedi, although some people will initially believe that they are. After you have thrown the ball downward, you cannot exert a force on it anymore. You can't do anything to change its motion anymore. Its motion is dictated by the gravity of Earth. And therefore, after the release of the ball, its acceleration is 9.8 meters per second squared down. Doesn't matter whether you threw it or not. And if you believe otherwise, then you have Jedi powers, which congratulations to you. You're awesome. All right, let's try another one. A person standing at the edge of a cliff throws one ball straight up and another ball straight down at the same initial speed. So let's say this one goes up 10 meters per second, and I simultaneously throw this one down at 10 meters per second. Okay. neglecting air resistance, so we're in free fall, the ball to hit the ground below the cliff with the greater speed is the one initially thrown upward, downward, or neither. They both hit at the same speed. So think it through, talk it over with your physics compadres, and when you're ready, unpause the movie and let's see what the answer is. Right, they are both going to hit the ground at the same speed. This one is a little tricky unless you're thinking through it clearly. But let's talk about the ball that we throw down first. So I throw it down and it's going to hit the ground. It had some initial velocity, which was 10 meters per second down. And then gravity is going to accelerate that to go faster and faster and faster downward until it hits the ground at some speed right before it hits the ground. Okay. What happens to the ball that I throw up? The ball that I throw up is going to go up and up and up, going slower and slower and slower until it stops. Then it's going to start to fall back down. And here's the important thing to observe. So you go faster and faster down. When it reaches the height it initially had, so let's say it was initially going 10 meters per second up, when it returns to that same height, because free fall is symmetric, it's going 10 meters per second down. So now it's in precisely the same situation that the ball that I threw down at 10 meters per second is. And therefore, it's going to hit the ground at the same speed.